Alright, our last objective in our last video of this short unit is to rationalize both monomial and binomial denominators. And for part 2 of this video, we're going to be working just with binomial denominators. Now these are a little more complicated because you notice we have two terms in the bottom. So if I multiply just by root 7 over root 7, it won't totally disappear because it would also multiply to the 5. So what we use is the little trick that we talked about earlier of conjugates. And we multiply the fraction by both, or the numerator and denominator, by the conjugate to whatever the denominator is. So 5 plus root 7, the conjugate to that is 5 minus root 7. So same two terms, just plus minus switches. We do that in the numerator too. So, sorry for my handwriting. So, the way this works is, in the numerator, we're just going to distribute the 6 to both of those terms. But in the denominator, we have conjugates, and we're going to use that little conjugate shortcut that we learned. So I'm going to do the numerator first. This is going to equal, let's see, 6 times 5 is 30, minus 6 times root 7. Well, one's in a root and one's not, so this is going to be 6 square root of 7. And there's nothing to simplify here. 30 and 6 root 7 are not like terms. In the denominator, using that conjugate shortcut, remember a plus b times a minus b, you do the first number, or the first term squared, minus the second term squared. So in this case, the first term is 5, and the second term is square root of 7. So 5 squared, I'm going to rewrite this again. The denominator is 5 squared, which is 25, minus square root of 7 squared, and as you know, these cancel out, we just get 7. And so our final denominator here is just 25 minus 7, and that is going to be 18. My apologies, I did not write the numerator. I'm going to catch up with that now. That's still 30 minus 6 root 7. So 30 minus 6 root 7. And the last thing we do is we look for anything that can reduce. So the root 7 is inside the root, so that's not... that doesn't apply, but 36 and 18 all divide by 6. So I can reduce them all at the same time. So 36 and 18 each simplifies by dividing by 6. So this is going to become 5 minus 1 root 7. So I'll just write root 7 over 3. So this is still simplifying a fraction. I know it looks a little more complicated, but that's all we did. We simplified the fraction. They all divided by 6. So that's our answer. One more example for this. We'll do the same thing. We'll take the conjugate of the denominator. So that is 8 plus square root of 5. Whatever that denominator is, same thing, except plus minus is switched. So 8 plus root 5. The numerator distributes, or the 3 plus root 11 distributes in the numerator, I should say. So let's see. This gives us 3 root 11 times 8. Is 24 root 11. You notice the 3 and the 8 multiplied because they're both on the outside. 11 had nothing to multiply with. And then plus 3 root 11 times root 5 is 3 root 55. You notice this time the root 11 and the root 5 multiplied together, but the 3 had nothing to multiply with because there were no numbers outside of the root. In the denominator here we have, we'll do the conjugate thing, so we'll do 8 squared minus square root of 5 squared. And I'm going to kind of do this all at once. Our final answer here, our numerator is not going to simplify. It's 24 root 11 plus 3 root 55. But our denominator here, 8 squared is, we'll do this in a different color. 8 squared is 64. And then root 5 squared, those cancel out, so that's minus 5. So 64 minus 5 is 59, so our denominator is 59. Now, I will look for, just in case it reduces, anything that cancels out. 3, 24, and 59 actually have nothing in common. 3 and 24 do, but 59 doesn't. So this can't reduce like the last one could, so we are done. It is an ugly answer, but notice that the denominator no longer has a square root in it. So that is what we've done. We have rationalized the binomial denominators in both of these cases.